Everything you know about Neanderthals is wrong. Our species clings to the myth that we won because we were smarter, but the data says otherwise. Neanderthals had brains up to 15% larger than ours, and their kind thrived for 50,000 years longer than Homo sapiens have even existed. If intelligence means brain power and survival, the evidence points in one direction, and it's not ours. This is not the story you expect. Neanderthal brains were not just large, they were on average larger than ours. Measurements from dozens of fossil skulls put the typical Neanderthal cranial capacity between 1,400 and 1,600 cubic centimeters. Modern humans, by comparison, average about 1,350 cubic centimeters. That is a difference of 10 to 15% in favor of Neanderthals. The numbers are not from a single specimen or a fluke. They come from a broad sample across Europe and Western Asia, spanning hundreds of thousands of years. Anthropologists use standardized protocols to measure endocranial volume, filling the empty space inside fossil skulls with beads or liquid to calculate the true internal capacity. These are the same methods used to compare brain sizes across primates, apes, and even dolphins. And everywhere else, a bigger brain is taken as a sign of greater cognitive ability. In other mammals, especially our closest relatives, brain size correlates strongly with learning, innovation, and problem-solving. But when it comes to Neanderthals, the usual logic gets quietly set aside. The data is clear and consistent. Neanderthals had more brain volume than we do. That anatomical head start is not a matter of opinion or outdated science. It is a measurable fact, repeated in every comparative study for over a century. If brain power is supposed to be the metric of intelligence, Neanderthals start with an advantage that Homo sapiens have never matched. Neanderthals endured in Europe and Western Asia for at least 350,000 years, possibly as long as 400,000 years. Their story spans a timeline that outlasts the entire existence of Homo sapiens so far. While modern humans trace their earliest fossils back about 300,000 years, Neanderthals were already established, surviving through cycles of glacial cold and brief, unpredictable thaws. The climate of Ice Age Europe was not just cold, it was volatile. Temperatures could plummet for centuries, then swing back toward milder periods, only to freeze again. Massive ice sheets advanced and retreated, reshaping the land and forcing every living thing to adapt or vanish. Neanderthals weathered these changes again and again. Fossil sites show their presence from the Atlantic coast to the Altai Mountains, across environments that ranged from open tundra to dense forests. They hunted mammoths and woolly rhinos, gathered plants in brief, fleeting summers, and managed to persist where few large mammals survived for long. Archaeological layers at sites like La Ferrasi and Mezmaiskaya Cave reveal occupation through multiple glacial cycles, with stone tools and bones stacked in sediment that records thousands of years of shifting climates. Measured by sheer survival, by the ability to adapt, endure, and maintain a lineage across the harshest environments on Earth, Neanderthals passed a test that no modern human society has yet matched. Their resilience is not a footnote, it is a central fact. For hundreds of millennia, they succeeded where extinction was always just a winter away. A Neanderthal toolmaker sat with a chunk of flint, turning it over in his hands. He wasn't chipping at random. The Levallois technique demanded a plan, shaping the core in a precise sequence, preparing surfaces and angles so that a single controlled strike would release a flake already designed in the mind. This wasn't trial and error. It was geometry, memory, and foresight working together. Archaeologists call it a conceptual leap, envisioning the finished tool before it exists, then working backwards through each step needed to create it. But Neanderthal ingenuity didn't stop at stone. At sites like Koenigsauer and Campitello, black lumps of birch tar have been found stuck to stone points. Making this adhesive required more than collecting bark and lighting a fire. Birch tar only forms when bark is heated in a low-oxygen environment and held at temperatures between 300 and 400 degrees Celsius. Too cool and nothing happens. Too hot and the tar burns away. Experimental archaeology shows how easy it is to fail. One slip in temperature or timing and hours of work are wasted. Yet Neanderthals mastered this process, producing reliable adhesives for hafting stone to wood. Their technology was not accidental. It was the result of careful observation, repeated practice, and the kind of procedural thinking that modern chemists would recognize. These were not simple foragers. They were engineers, working with fire, materials, and abstract plans. Deep inside Spanish caves, red pigments still cling to stone after more than 64,000 years. In La Pasiega, a ladder-like motif sits beneath layers of calcite, its age fixed by uranium-thorium, dating at nearly 65,000 years, far older than any evidence for Homo sapiens in Europe. At Maltravieso, a hand stencil in red ochre presses the outline of a Neanderthal palm onto the wall, dated to at least 66,700 years ago. These are not accidental marks or natural stains. The pigments were mixed, carried, and applied in darkness, far from the cave mouth, in spaces chosen for their resonance and secrecy. Neanderthals were not just surviving, they were creating symbols and leaving messages for minds that would come after. On open ground in Croatia, eagle talons turned up at Krapina, cut and polished, bearing grooves and wear from string or sinew. These claws, gathered and shaped more than 130,000 years ago, were never tools. They were ornaments, worn for meaning only their makers understood. In southern Spain, perforated shells and lumps of ochre have been found in Neanderthal layers. Some shells were painted, others used as pigment containers, objects collected not for food but for display and color. In burial sites from France to Iraq, Neanderthal bodies lie in deliberate pits, sometimes with animal bones or pigment nearby. The dead were not abandoned. They were placed with care, their resting places marked by choices that speak to memory and shared belief. These acts, painting, adorning, burying, are the signatures of a mind that thinks in symbols, a mind capable of seeing beyond the present moment. The evidence is written in pigment, bone, and earth. Neanderthals lived in a world of meaning. Neanderthal speech was not just a guess. It is written into their DNA and bones. The FOXP2 gene, often called the language gene, carries two key changes in humans that are missing in chimpanzees. Neanderthals had both of these, just like us. When this gene is damaged in people today, the result is severe speech and language impairment. Ancient DNA from multiple Neanderthal fossils, sequenced and cross-checked for contamination, confirms they carried the same FOXP2 protein variant that allows for complex vocal control. Their anatomy backs this up. In Kebra Cave in Israel, a 60,000-year-old Neanderthal skeleton preserved a hyoid bone, a small horseshoe-shaped bone in the throat that anchors the muscles needed for speech. Detailed studies show the Kebara hyoid is virtually indistinguishable from our own, both in shape and in how it handled stress during life. This means Neanderthals had the physical setup for a modern vocal tract, with the flexibility for a wide range of sounds. Their ears tell the same story. Reconstructions of Neanderthal middle and outer ears show peak sensitivity between 2 and 4 kilohertz, the very range where human speech is most intelligible. This tuning is not found in chimpanzees or earlier hominins. It is specialized for picking up the subtle shifts in tone and consonant sounds that language depends on. Genetics, vocal anatomy, and hearing all line up. Neanderthals were equipped for spoken language. The evidence now demands an explanation for why they would not have talked, not the other way around. Neanderthal skulls tell a story of specialization. Their eye sockets, known as orbits, were noticeably larger than those of early modern humans, even after adjusting for body size. In primates, bigger orbits mean larger eyes, and larger eyes demand a more expansive visual cortex to process all that incoming information. Endocast studies confirm it. Neanderthals devoted a greater share of their brain volume to the occipital region, the hub for visual processing. This neural investment gave them a visual advantage in the dim, shifting light of Ice Age Europe, sharpening their perception where survival depended on reading the landscape, tracking prey, and spotting danger before it struck. A Neanderthal hunting party faced animals that could kill with a single blow: woolly mammoths, rhinos, and giant bison. Archaeological sites are littered with the bones of these giants, bearing cut marks and impact scars from thrusting spears. This was a dangerous world, and the evidence goes deeper than the hunt itself. Neanderthal skeletons often show severe injuries, broken bones, crushed limbs, even skull fractures, yet many of these wounds healed completely. This means injured hunters were cared for, fed, and protected long enough to recover. Survival in such a world demanded not just strength, but coordinated strategy and a social safety net. Here, intelligence meant planning, teamwork, and the ability to manage risk together. Every non-African today carries 1 to 2% Neanderthal DNA. Their tiny populations were simply outnumbered. Today, every person of non-African ancestry carries Neanderthal DNA, proof that intelligence didn't vanish, it was absorbed. Our story isn't one of triumph over the lesser, but of merging with equals. What we call progress often erases the very brilliance that made us possible. Thanks for watching.